Good morning. This is a demonstration of how to run chi-square statistics by hand. I'm going to do two examples. The first one, I'm going to do what I call a one-dimensional chi-squared, and the second one, I'm going to do what I call a two-dimensional chi-squared. For the first one, question number 1 here, in order to test the effect of acid rain on tree seedlings, you plant 100 plants of 4 species. So I planted 100 sugar maples, 100 white pines, 100 larch, and 100 red oak. Later you count the number of seedlings that died. So of my 100 plants, 47 sugar maple died, 58 white pine died, 4 larch, and 10 red oak. So the question here is, are some tree species significantly more vulnerable than others? So how are we going to find that out? So you should always write a null hypothesis first. So my HO, or my null hypothesis, is there is no difference. And that's what makes it a null hypothesis. There is no difference. And what are we testing? We're testing the effect of acid rain. Oh, I can't spell difference. Difference. There's no difference in the effects of acid rain on these 4 tree species. And then I'm going to write them in sugar maple, white pine, larch or tamarack, and red oak. The next thing we need to do is organize our data into a table where I can write observed and expected. So I'm going to write, I only have one variable. The one variable I'm testing the effects on tree species. So my one variable is tree species, and I'm going to write them down. So sugar maple, white pine, larch or tamarack, and red oak. And then I have, and then total. And then I only have one column because I only have one variable. And then I'm going to divide that column into observed and expected. The observed are how many I saw that I counted that had died from acid rain, or potentially acid rain. So there were 47, 58, 4, and 10. That's a total of 119. Now it's only one column, so the 119 is in the middle of that dotted line, because both these columns are going to equal 119. Now when we're doing one-dimensional equations, expected equals our total divided by the number of categories. So in this case, E equals our total of 119 divided by 1, 2, 3, 4 categories. So that's 29.75. So then all of these get 29.75. So then we need to put these into our equation. Chi-squared equals the sum of observed minus expected squared over expected. So how this works is we're going to add this part of the equation over and over again, depending on how many variables we have, or how many categories we have. So I'm going to rewrite it. Chi-squared equals observed minus expected squared over expected plus observed minus expected squared over expected plus. Now how many times do I add it together? I have 1, 2, 3, 4 different trees. So I'm going to add it together 4 times. Another way of looking at that is I have 1, 2, 3, 4 sets of numbers to calculate. Don't want to leave any numbers behind. I'm going to push this up a little bit. So then chi-squared equals observed of 47 minus the 29.75 squared over 29.75 plus our second variable here, our second tree, 58 minus 29.75 plus our third tree, oh, we forgot the squared, and our last tree. And then it's just doing math. I like to do the math at the same time. It's easier in my calculator. Well, 0, 0, 2, 1. I'm just going to, maybe I'll just put my 2 zeros. So the next one, 58 minus 29. It's riveting, I know. Oh, you guys can't see that bottom. I also like to keep all my columns nice and neat so that I can see my progress. And I typically always have 2 negative numbers and 2 positive numbers. And often they match. In this case they don't, but sometimes they do. So chi-squared equals 72.23. Now, I'm not a mathematician. I don't do significant digits. I'm more interested in you guys learning how this process works than getting stuck up on small mathematical rules. Your math teacher will make sure you do those right. But for today, this is just figuring out how to do the math. So 72, if you get to 72.1 because you rounded differently than me, or 72.3, that's okay. That's a very, very similar answer. What we need to remember though is that this is the calculated chi-squared equals 72.23. We used a calculation and a calculator to find out to calculate calculated chi-squared. We need to find out if that is greater or lesser than critical chi-squared. Critical chi-squared comes from a table. So to find the critical chi-squared on this critical table of values, we need to find out a few things. The first thing is our degrees of freedom, which in a one-dimensional problem, degrees of freedom is the number of categories minus 1. So if you guys recall, we had 4 categories, right? 1, 2, 3, 4 trees, 4 categories. So our degrees of freedom is 4 minus 1, so 3, which means we're going to go to the third column down, which is this one here. And I'm going to use a piece of bright colored paper in a second. The other thing we need to know is what column here to use. And we always, this is called alpha, and we always use 0.05. It is a very rare situation that you don't use 0.05. This is the accepted amount of error that scientists work with, is 5%. So basically, what we're looking for here is if this is our acceptable line, our degrees of freedom is 3, so we need to follow our third row across all the way to the column that's 0.05. And we find that our critical chi-squared is 7.815. And basically what this is saying is if this row is our standard acceptable amount of error, anything greater than that we are going to reject, and anything less than that we're going to accept. This is our cutoff line for what's acceptable. So if we reject anything out of there, that means our null hypothesis is rejected and we have a difference. Anything less than this we're accepting, that means our null hypothesis is accepted and there is no difference. So back to our math here. Our calculated chi-square, I always like to put 2 dots on the big number and 1 dot on the little number. So 7 is the little number, 72 is the big. So my calculated chi-square is greater than my critical chi-squared. That means it's crossed that critical line, which means we reject HO. And then you need to write a concluding statement. There is a difference because we rejected our HO, right? There is a difference. And what is there a difference in? In the effects, I'm going to run out of room here, effects of acid rain for these 4 tree species. And I'm going to run out of room, so I'm going to stop there. But that should give you an idea of how to do a one-dimensional chi-squared. I'm going to do a second video where I show you how to do a two-dimensional chi-squared.